This week, near miss, bullseye, and a lifesaver. With Spencer away this week, I've been left drone alone. We're in Andalusia, Spain, where some important testing is going on, which could be crucial to the way the global economy moves in the 21st century. Why? Well, last month, China joined an exclusive lineup of countries allowing drone deliveries. After its government gave the official go-ahead, the US is expected to follow suit within weeks. Yes, after years of talk about everything from duvets to dog food making its way directly to you through the skies, it's starting to happen, whether you like it or not.
This is just one drone that could be making one delivery. But in the not too distant future, our airspace could become a much busier place. The biggest internet shopping companies in the world have been talking about drone deliveries for some time. And here they're trying to find a way of making this possible safely. More on that in a moment, but first, Dan Simmons has been to California to meet the people behind what's expected to be the US's first commercial drone delivery service.
Blink and you'll miss it. Travelling at 80 miles an hour with a range of 100 miles, the new Zip drones are fast, and they stop even more suddenly. The onboard navigation equipment brings the aircraft to within a metre of the landing rig, tripping the sensors, which jolts the zip wire upwards to catch its tailhook, plucking it out of the sky. Delivery is pretty sharpish too. When the GPS module confirms the aircraft is in position, a catch is released and the goods fall to Earth. If you've not seen a Zip drone before, you may be thinking, I should have ordered the calzone, because any other pizza would need some fresh toppings after a landing like that. But the well-protected, precious cargo here is blood or plasma. And that could save someone's life.
When someone is having a medical emergency and needs a product, speed is basically everything. And our goal is to be able to provide access to a wide range of medical products so fast that the patient doesn't actually even know it wasn't stocked at the hospital to begin with.
The company says doctors in rural hospitals in the US would be able to send an order by text. The blood run would begin within 2 minutes. And if you think that's a stretch, Zipline's already doing it. Here in Rwanda, and soon in Tanzania. This is Nest One, the site we first visited just outside Kigali in 2016. While this base and its drones are monitored from California, on the ground it's now exclusively run by Rwandans. And the 18-month track record is impressive.
Zipline's team in Rwanda has delivered over 7,000 units of blood, flying over 300,000 fully autonomous commercial kilometers. And then of those, about 1,100 are emergency deliveries, so a delivery where a patient is really relying with their life on receiving that product quickly. The team has been able to have a very, very big impact on the healthcare of a large number of people. What is happening now is that it's possible for states and cities to independently ask for permission to fly and present their own safety cases for how that can be done in a way that's safe for the people on the ground.
Overlooking California's Pacific coastline lies Half Moon Bay, Zipline's original home, and where it still carries out research and built this year's new model. And this is what they've come up with. It's faster and more efficient than the previous version for a number of different design reasons. One of them has been designed by Paul here, and this is the airframe. I mean, literally, look how light that is. How heavy is this?
It's 1.09 kilos.
And what are the other advantages of something like this?
So we designed this airframe to be very modular. So this is the skeleton. We could ship this around the world and all the other pieces bolt on and totally interchangeable.
Okay. So now something else that's a bit different with this design is they've moved the engine to just above the fuselage. So before they had two engines underneath each wing, and you might expect an aircraft to have an engine right at the front as well. This is pretty unusual. Brendan's responsible for this particular part of the design. Why on top of the aircraft?
So one of the disadvantages of the previous design is that if we lost a motor, we'd have asymmetric thrust. So the tail would have to fight it, and the plane would often become unstable.
So it could go around in circles.
Right, yeah. In addition to that, we're fully redundant as far as power goes. So if you lose a motor, a single motor can actually fly the plane and complete a mission.
And I hear being on top of the aircraft, it's a lot less noisy.
Yeah, you can imagine the fuselage would absorb some of the sound there.
Okay, cool. Sven, you designed the tail.
I did.
Why is it a V-shape?
It gets it out of the prop wash, which is right down the center of the tail boom. It lets the surfaces be outside of that area of the flow. And then also, because of our unique landing situation going on, where a line actually trails the bottom of the tail boom and catches on a hook at the end. And if you had a traditional horizontal and vertical stabilizer, the tail on the horizontal part of the tail could get hooked onto the line.
All of those changes mean that this aircraft is, they claim, the fastest of its type for drone delivery, and it will go further than any other aircraft. And that's in large part because those designs allow for this huge 9-kilogram battery to be put in the front of it, twice as big as the previous version, and that slots into here. The new model is a lot quieter than the previous one. In fact, in this rural environment, I can actually hear the birds singing to each other more loudly than the drone, and that will no doubt come as great comfort to anyone who's worried about the din of buzzing in the sky when drones start delivering for real. Safety will be the highest priority. The Zips operate between 40 and 100 metres up and away from airports, so passenger planes won't be a problem. But what about the risk of drone-on-drone crashes?
Whenever any plane is able to detect any other plane anywhere in its vicinity, both of those planes will actually change their altitude in order to ensure that they're not on the same vertical plane as any other vehicle.
To make sure they don't crash?
That's right.
That's governed by Zipline's own air traffic control system. But what about other people's drones, not on their radar?
Basically, the vehicle will have a sense and avoid system that will allow it to detect any other vehicles, anything that's like you said, not in the Zipline ecosystem, and make, if necessary, evasive maneuvers. There's radar systems, there's LiDAR-based systems. There's also actually one that we're investigating that uses microphones to detect other vehicles.
You said you're looking into that area. Does the aircraft currently have
No, there's no current sense and avoid system.
So at the moment, Zipline reports in to US and Rwandan air traffic control, systems that are unlikely to be able to cope when more drones take to the sky. So far though, they've had no crashes, and should one lose positioning or comms, it flies straight back to base. In the coming weeks, maybe days, the US authorities are expected to hand out their first commercial drone delivery licenses. How many operators will follow will largely depend on safety, need, and perhaps whether we prefer convenience over the buzz.
That was Dan in California, and he joins me here, as does a drone, which is rather noisy.
Yeah, it is. They really are, aren't they? It really does to show you how important it is where the engines are placed on drones. At the moment, they tend to be out and unprotected, which makes it quite noisy down below. Whether, as us members of the public are going to put up with that remains to be seen, but there are things you can do to reduce that level of noise.
Well, that's one issue. Another is that it seemed in your report that we were still reliant on traditional air traffic control, the same as planes.
Yeah, I mean, Zipline say that they keep their own planes separate from each other with their own systems, but there's nothing to stop a Zipline plane hitting maybe an Amazon plane, because they're on two separate systems, apart from those sensors that are on board each of those two aircraft. Now, if they fail, there's no overarching system that will keep those two planes apart, and that is still a problem in the States.
So a pretty substantial issue that needs to be overcome. Thank you very much, Dan. And that's exactly what Vodafone are trying to deal with here.
At this testing facility, they're experimenting with using the mobile network to create a low-altitude air traffic control system for drones. Each would be fitted with a SIM card, making it possible to autonomously control and track them. This could work across a region or a country and would hopefully mean many safe flights free from collisions or disappearances.
Well, this is the prototype that they've been using today. Inside you've got GPS, a gyroscope, a camera under here. But also, if we take this off, you can see there's a mobile phone. So we're not quite at the stage where it's running with a SIM inside, and clearly there is a little way to go, but at least this is a decent way to be able to test things.
The onboard camera would still help it avoid bumping into unexpected obstacles like a bird or indeed fellow drones. Whilst this one can only carry a load of up to 3 kilograms for 15 minutes, or go longer with less weight, there are of course drones that can do more and battery life will improve. The plan here is to employ both GPS and the mobile network. Although that network can currently only locate to within 50 metres, it should serve as some protection from GPS spoofing or hacking. On top of that, artificial intelligence will be at play, aiming for better accuracy and to help keep vehicles out of geofenced no-fly zones. But if we're looking at deliveries like this becoming the norm, there's likely to be a lot of them in the sky at once.
For a future with multiple, maybe hundreds, maybe thousands of devices flying over urban areas, we will no doubt need more advanced networks, and that's why we are preparing with 5G and even bringing some of the 5G techniques onto 4G.
But what happens when they drop signal?
So they don't fall. So if you imagine on your flight path, you are just passing through an area on which maybe temporarily there is poor coverage or there is interference, you can be pre-programmed to continue with your flight path and just keep doing what you're doing, knowing that you're going to recover the signal, or return home.
Initially, they just fly through designated flight paths in the same way that planes do, just at a lower level. They're currently being tested at about 120 metres. But as the technology evolves, it's hoped they'd be able to pick up or drop off on your doorstep. But do people actually want all these drones flying overhead?
Well, we've been through that process before with aeroplanes and even with cars, and I think starting off with defined routes is a very good idea, but generates much more benefit with the least disruption. And I think what you'll probably find is these things are used as a trunk route to start with, and then I think they will be used in very specific areas, for instance to fly to places like hospitals where they have a zone on the top of the building you can use. So I think we're still a little way away from everyone having a drone park in their garden.
Although you could find that your home is under one of those drone trunk routes. Vodafone may be the ones testing this, but it's not just about one provider.
All our work has been made public and is available for everyone to use, and we expect other networks will implement it in the same way we've implemented it. So we're not making money out of royalties or patents or licensing.
The technologies hope to be ready next year, which is also when the European Commission has said it wants safe commercial drone services to be available. But above and beyond all the excitement or dismay the idea may muster up, nothing can happen until the regulations are in force.
Hello and welcome to the Week in Tech. It was the week that Google Chrome blocked videos from autoplaying with sound, Bitcoin's price volatility inspired a video game, and Tesla, again, temporarily suspended production of its Model 3 cars. It was also the week that ethics were put at the heart of future artificial intelligence developments by a UK Parliament report. AI should never be given the power to hurt, destroy, or deceive, it said. In Europe, authorities want to force tech companies to hand over communications of terror suspects within hours of a court order, even if the data is held outside its jurisdiction. And Facebook's woes continue. A US court ruled the social media giant should face a class action lawsuit. It's for allegedly identifying users with facial recognition software without their explicit consent. Facebook started rolling out the feature to its European and Canadian users this week, but at least asked for permission first. And finally, you want to join him for a pint? I must warn you, he's not the best drinking buddy, as he can't really join in. Fred is the creation of Engineered Arts, whose workshop Click visited a few weeks ago. The bot is busy promoting the upcoming season of the science fiction TV series Westworld. He features a skin-like material and hair on a mechanical body. Creepy.
With Vesuvius brooding in the background, excavations are going on at Pompeii as well. Archaeologists and historians have already been thrilled by many exhumed wonders of the past.
Archaeology might make you think of pickaxes, paintbrushes, and needing a whole lot of patience. But the tools of archaeology are changing. Question is, can one of these ever be replaced by one of these? This is Google's Open Heritage project. Released this week, the project throws open a tomb of high-res 3D scans of centuries-old buildings and monuments. All the scans are free for anyone to reuse, as long as what you create is non-commercial. The full online collection spans 18 countries and includes sites like the Chichen Itza in Mexico, ancient Corinth, and here, the 1,000-year-old temples of Bagan in Myanmar. Google are hoping that by making this sort of data available, all sorts of people will find interesting things to do with it. A bit like this, perhaps. This is a virtual reality experience made with one bit of the data.
In the Amyar Jang, we find 5 Buddhas with their hands in gestures.
The experience takes you on an immersive tour of 2 of Bagan's temples. All over the walls are these incredible paintings, and they're showing the previous lives of Buddha. And you can get so close you can really see the details. As well as learning about the history of the site, you see some of the damage that was done during a major earthquake in 2016. But what's great about having this sort of data is that preservationists can use it to restore the temple to this exact state with millimetre precision. Scans of this and other sites around the world could form an invaluable tool to preserve places even if they're damaged or destroyed. While Google may be shouting about this project, it's scanning company SciArc that has done the legwork on the ground to gather all this data. Much of it's been captured using LiDAR. That's a technique of firing lasers to record how far away things are. Do it millions of times and you get something like this. Combine that with thousands of photographs and you can get some pretty detailed data.
We are genuinely excited to find out and see how this data is going to be used by the education community and the heritage preservation community globally, how students will use it, how teachers may use it.
SciArc has over 100 sites in its full library, so we could see even more data come online soon. For now though, the 28 that are available will have to do. I for one can't wait to see what people make with it.
Back to drones. Only a couple of months ago, we showed you how firefighting crews could be using them to gain safer access to buildings in emergencies. But on the east coast of Australia, it's a very different issue that's being dealt with. In a place where shark attacks are all too real a problem, they're playing lifeguard. We sent Nick Queck to find out more.
The sandy shores of eastern Australia. A haven for sunshine, surfers, and occasionally sharks. Last year there were 15 unprovoked attacks on Australian coasts, and just this week 2 surfers were bitten by the fearsome predator. Patrolling the Gold Coast since last summer, Westpac Little Ripper drones have been surveilling for sharks and alerting lifeguards and swimmers. They work with a custom piece of artificially intelligent software called the Shark Spotter, which is scarily effective.
We have more than 90% accuracy with sharks. A trained human operator flying on a helicopter has accuracy around 20 to 30%.
90% accuracy. The program uses object recognition to identify and decipher between people and marine life, and it gets smarter as it goes.
We have to draw bounding boxes around each of the objects and say what kind of or what type of object is that. It has to be done, it's a manual process.
How long does that take?
Well, it takes a long time. We have annotated manually more than 20,000 frames and used it for training and testing the algorithm.
Once a shark is detected, the drone hovers near swimmers and warns them via an onboard loudspeaker that it's nearby.
Huge swells in the waves means that sending out jet skis or human divers is really too dangerous and pretty much pointless. But having an eye in the sky can really help.
When you have the bird's eye view, you can easily identify and tell the difference between sharks, dolphins, manta rays, turtles. But also it's been really good for search and rescues where a drone can find a patient, especially in high seas, high swell. They can tell you exactly where the patient is and probably the best way to get them back to shore as well.
Earlier this year, the world's first drone rescue was successfully completed by one of their fleet.
Took off, flew down the beach about 800 metres, found the kids, deployed the pod to them. They grabbed it straight away. It took about 70 seconds from takeoff till they had the pod in their hands, and then that helped wash them in. They couldn't swim in on their own. They were in a bit of trouble. They're pretty lucky we were there that day.
To pull off this feat, the drones are equipped with a neat little package.
So underneath here there's a little mechanical arm which is carrying this payload, and when it's time to be deployed, a switch is flicked. This drops down, and upon impact with the water, it rapidly inflates. It's enough to carry 4 people for 24 hours.
As well as improving response time, the Ripper Group claims its system can reduce cost. Instead of having several lifeguards, you could have one drone, for instance. But the idea is not to replace human lifeguards.
No, it's like another bit of equipment for us. For example, our jet skis. You know, people were a bit worried about jet skis, then maybe we might have to have less lifeguards because we have a jet ski now, but you learn to use them in the correct way and the correct conditions. So in no way it's going to replace people. In no way is it going to replace helicopter rescues. It's just another bit of equipment we can use to save someone's life potentially.
It's not all rosy though. These are aircraft working near water and people. Recently, one of their drones malfunctioned and had to do a crash landing in Byron Bay. They patrol hourly for less than 30 minutes, so they're only watching half the time. And of course, there's the weather. High winds or rain means no flying for Little Ripper. Other waterborne solutions exist, such as the static Clever Boy by Smart Marine Systems. It uses sonar to detect distinctive shark movements and sends a text message to guards to raise the alarm. It comes with underwater stereo cameras too, which verify the findings. The kit's being used in a $16 million government project to mitigate shark attacks. But will these high-tech solutions ever really take off?
Price is a big factor that will change significantly. We've seen that in the last 3 years. Our first iteration of the Westpac Little Ripper Lifesaver was $160,000. We're now down to $15,000. There's only 400 beaches around Australia that are actually patrolled by lifeguards. And there's 2,000 beaches around the Australian coastline. So we want to be able to patrol that other 1,600 beaches.
Dr. Sharma is now cooking up a system to spot crocodiles, which thrive in muddied waters, making them harder to see. And he's training the kit to identify signs of swimmer distress, meaning lifeguards could get to the scene before there's a chance of drowning. Right now, at least, they can help us swim with a little less worry.
Nick Queck there, working as hard as ever. That's it for our drone special. Spencer will be back next week. In the meantime, you can find us on Facebook and Twitter at BBC Click. But from Spain, it's adios. Thank you for watching.